and Professor Brabec will be telling us about accelerating emerging photovoltaic technologies. So you have 20 minutes. Good luck.
Thanks a lot. Let me just start to introduce myself and the research center in Jülich, where we are operating these high throughput experiments. Jülich is a governmental research center in Germany. It's fairly large sized. So we have in about 812 million budget, which is spread over 3 research fields from energy, information, bioeconomy, distributed in 11 institutes, and these 11 institutes have 80 institute sections. And if you look to these 80 institute sections, then 13 of them are from the Institute of Energy and Climate Research, and I myself am a member of the Helmut Institute Erlangen-Nürnberg, which is the institute number 11. And at this institute, we do hydrogen and photovoltaic research, and I myself, I'm director for the photovoltaic research. The overarching challenge we are working on is this materials acceleration, specifically in organics and perovskites or emerging photovoltaics. And the challenge we always have is if you try to optimize a new material, the number of variations is close to infinite. If you want to do 10 materials, in that case 10 molecules, and you want to understand how to get the ideal composite for charge generation, you do 100 variations, you have 1,000 composites. Then you want to go to the mesoscale, to the film formation. Again, with 100 variations, you have 100,000 layers, and then you want to go to the device. And if you have different interfaces, then easy 100 variations. You would be at the 10 million devices you might have to optimize before you are the product. So this is really beyond what we can do now. This idea is how can we accelerate such complicated problems, and this is this material acceleration, and we need descriptors on every of these every of these stages, and we need optimization criteria from the device or product level. We are doing this in a dual approach. We're doing this mixed knowledge-based science. We have a lot of domain knowledge in the emerging PV field, and we are coupling this with the data-based science, which is the automation and data. And this is, we are setting up automated platforms, and we are starting to link these platforms to the data science and the predictive machine learning part. So how does this look like? In principle, you are designing lines like you see here. I will tell a little bit more about that in the next minutes. The governing principles, the design principles behind these lines is that we want to incorporate all knowledge which is available. So this means we are operating databases which even go beyond the data which are generated by this line, but we are coupling several lines. We want to get these laboratories operating independently, self-driven laboratories, so autonomous operating. What we are looking forward is this factor of 10 in the acceleration for the discovery and deployment of new materials. And we are operating these lines for photovoltaics, for solution processed photovoltaics, but you understand that these lines can be adapted to many other processes as well. The automation portfolio we are currently having is starting from the synthesis of automated synthesis of molecules or quantum dots. We have the ink formulation, typically on the hand of pipetting robots. We go to thin films. Right now, most of this is spin coating, and there are first experiments on the blading and slot die coating. We can run full devices, inclusive characterization and degradation. So the value chain we are trying to build up is from the material towards the final device verification, and have as a working stream which is covering all the TRLs till the prototyping. The platforms we have so far developed is on the ink system and ink formulation. We are operating pipetting robots, like you see here, this Taken Freedom. This is apologies. This is a pipetting robot which is doing mixing, drop casting, and some characterization. The next level of complexity are our modular lines. You see here the spin bot. This one has a small spin